Okay, to solve this inequality, this third degree polynomial here, but we would treat, regardless of the degree, we treat these all the same. We're going to break up our real number line by our zeros. So we have 3 zeros here, right? This factor, if we set to 0, so I'm kind of skipping a step, would give me a 0 of -8, or an x-intercept. This one would give me an x-intercept of 2, and this one would give me an x-intercept of -6. Right, so that's where it's crossing the x-axis, going from positive to negative. So that's what we want to know, where it's positive. So I break up the real number line like this. So I want to cover all my x values. So from negative infinity up to my smallest value, which is this one, -8. And because this is included, I'll just go ahead and put the brackets on all of these. And then we're going to go from this 0 to the next one. So that's -8 to -6. And then I'm going from -6 to 2. And then I'm going the rest of the way to infinity. Okay, so these are my potential answers to this inequality. I just got to figure out which one of these would give me a true statement. And we do that by picking a test value. So I will choose a test value in here of -9. Here the obvious choice is -7. Here the obvious choice is 0. We always like the x value of 0 there. And here I think a good choice would be 3. Okay, so those are my test values. So when I test those, I got to plug them in to this inequality. So let's start with the -9 and see what happens. When I plug in -9 here, do I get a true statement? Okay, so I want to know, is that greater than or equal to 0? If it is, then that test value kind of speaks for everything in the interval. Everything else in that interval will give you the same result. So let's see, this is 2 times -1 times -11 times -3. Is that greater than or equal to 0? So I got a negative times a negative times a negative, which is a negative. So I have 2 times a negative number. It doesn't really matter what that is, right? I just care that it's negative. So that is not greater than or equal to 0. So that guy is out. That is not part of the solution. And then I just repeat that process 3 more times, right? We had 3 zeros, which means I have 4 intervals to check. All right, let's try the -7. -7 plus 8. -7 minus 2. -7 plus 6. Is that greater than or equal to 0? So this is 2 times 1 times -9 times -1. Is that greater than or equal to 0? And this one is, right? Because I have a positive times a positive times a negative times a negative. So those two multiplied together give me a positive. So that one's going to work, right? So this is part of my solution. So that's part of my solution so far. And I got to do this 2 more times. Okay. Moving on, let's try the 0. This one should be easy. Oh, by the way, sometimes with these you get this first coefficient right here is negative, right? And you'll have to really be careful, because if I have a negative in front of this 2, then it would just change, it would actually flip the sign, right? So that'll change it, so you gotta watch out for that. In this case, we don't have a negative there. So now I'm gonna choose the 0, 0 plus 8, 0 minus 2. We love 0 as a test point. By the way, if you move on to calculus, you'll do this kind of thing a lot when you talk about derivatives and whether your function's increasing or decreasing. It's really the same process. So let's say I got a 2 times an 8 times a -2 times a 6. So everything's positive except the -2, which would make everything negative, right? And negative times this positive result would be negative. So that is not a true statement. So he's out. And then you can kind of guess what's going to happen. This one is probably going to work, but we're going to test it just the same. So I'm going to choose my test value of 3. 2 times 3 plus 8. 3 minus 2. 3 plus 6. And in this case, everything's going to be positive, right? Positive, 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 positive. So it's going to work. So when I multiply 4 positives together, it would be 2 times 11 times 1 times 9. Doesn't matter that that's whatever that is, 22 times 9. It doesn't matter what that is. It just matters that it's a positive value. So that means that test value works, which means this test value works. So that is my answer, those two sets. So now the question is, how do I write that down using interval notation? -8 to -6. Anything in that interval, including the endpoints, will give me a correct result, will give me a positive value. And then we use the union symbol to infinity. Any x value in those sets will give me a positive or non-negative value. And the reason we're including the endpoints is because this guy right here, because that's included. So we would always do that. But you can test it. If I plug in -6, you see what happens. You get a negative. When you plug in -6 here, this factor gets 0. And it doesn't matter what these are, because 0 times this is 0. And 0 is greater than or equal to 0. If that were just the greater than symbol, then we would have parentheses for all of these brackets. And remember, infinity always gets a parenthesis.